So on the first one, the first thing we should do is what?
Expand it.
Expand it. Okay, so I'm just gonna rewrite it. We're not deriving yet. When I expand this, we get natural log of x squared. And what operation separated the fraction in the natural log? Minus natural log of 4x plus 1. Now, I can leave it like this and use the rule of the natural log derivative, but I can do one more thing. What is that one more thing that I can do? Rewrite that in front. You may leave it just like that, but there's more simplification involved. So we have 2 natural log of x minus natural log of 4x plus 1. And y'all recall finding the derivative, right? It was 1 over that, correct? Now in this case, this coefficient right here, just leave that alone. So it'll be 1 over the x. And when I derive that argument, what is the derivative of the x?
1.
Do I really need to write the 1? You can if you want, but you don't have to. Then we have minus. Again, it's going to be 1 over that argument. And what is the derivative of that argument? And that is it. If you want to simplify, go for it, but leave it like that if at all possible on all the free responses. Good?
Got it.
Okay? For the next one, I'm going to give you a shortcut behind this after, only because the traditional thing works out almost every single time. So on this one, what should I do first? Did you find it? You did, okay. Can we bring the 2x to the front, maybe? No? No? Let's leave it just like that and see what happens. So when I'm finding the derivative, it'll be 1 over that argument. And then we derive that argument. Now, quick reminder, anything that is derived with the e is itself times the derivative of the power, right? So it's going to be itself times the derivative of that power, which is what? 2. And I want you to notice something. This is technically over 1, right? So isn't that basically gone?
Yeah.
So our final answer really in the end is what?
2.
2? Okay, do y'all care for the trick?
Sure.
Okay, if you care for it, here I go. There is a hidden base of e on all the natural logs, right? And what was the rule when you had the little one and the big value within the natural log? It is 1. So really in the end, we have the original equation as 2x. What is a derivative of 2x? Did I get the same thing? Yes, I did. So if you like that rule, use it. If you want to do it traditionally, you'll still get it right in the end. Okay? That's an equal to, by the way. Okay, let's do another reminder. Should I rewrite this piece?
Yes.
Okay, how would I rewrite this? 2 on the right side as a power. Okay, so let's rewrite this as cosine of 3x all square. If you want to put double parentheses, that's fine. I think the bracket kind of separates it and makes it neater. So what rule are we using here? Chain rule. So we have derivative will be 2 comes out in the front. We keep the inside as it is. And then we derive the next part. So are we deriving the cosine or the very inside? The cosine. What is the derivative of cosine? Ooh, what kind of sign?
Negative.
Negative sign. And you keep the inside as it is, and then you derive the very, very inside, which is what number? 3. Now keep in mind, that is not a minus. It is a negative sign. We're really in the multiplying 2 by the cosine to the negative sign to the 3. Good? Okay, any questions on this one?
Should we put?
Go ahead.
Do product rule when you're deriving inside?
In the inside, it's not a product rule, because cosine of 3x or sine of 3x is one component by itself. If it has sine of x and then 3x, x is in two different locations, then it's going to be product rule.
Should we put like
The negative to the front?
sign and parentheses?
Negative sign in parentheses. Where are we?
Just that.
The bracket is already a parentheses.
He's saying like just the negative sign. not
Should we bracket like?
Oh, you
right
mean
on
like
that?
right here?
No. I'm saying like should we like is that how we should write on the test? Right?
Uh-huh.
The brackets, okay.
Ideally, if you have a negative somewhere in the front, what I would do, a better answer of this would be take the coefficients and multiply them. Bring the negative to the front, and then you'll have cosine of 3x and sine of 3x. That's how you'll see it on the multiple choice.